Hi everyone, myself CA Jagadish, Assistant Professor, Department of Mechanical Engineering, Hindustan College of Engineering Technology, Coimbatore. In this session, we are going to see about finite element analysis. Basically, to solve a physical problem, we need three methods. Number 1, theoretical method. Number 2, practical method. Number 3, computational method. According to theoretical method, it takes more time with the help of equations and substitutions to get a result. According to practical method, we need an experiment and we have to demonstrate, and we need a one-time investment to purchase these all things to demonstrate and get the results. According to computational method, we also need a one-time investment of computer software to solve the problems. Finite element method. It is a computational method which is used in solving the engineering problems. It is a good technique widely used in all industries and all type of problems. For example, we can able to solve the problems and find the results for stress analysis, fluid problems, heat transfer analysis, diffusions, vibrations, electrical and mechanical fields. Here, the fundamental concept involves the dividing the object into finite number of pieces. It is known as elements or otherwise called as discretization. With this finite element analysis, we can able to find the solutions with known parameters and we can get the result for unknown values. This can be able to solve with the help of interpolation or approximation functions. This approximated variation quantified in terms of solution values at special element location called nodes. Through this discretization process, the method sets up an algebraic sum of the unknown nodal values and produces the approximate continuous solution, because the element size, shape and approximating scheme can be varied to suit the problem. The method can accurately simulate the solutions to give the exact answer for a complex geometry with the loading, and a good technique which is very much useful and it is a practical tool. The figure represents the finite element model which consists of elements and nodes. The FEA model converted from solid model. How to convert the solid model into FEA model? With the help of a discretization process. It is also known as meshing. Advantages of finite element analysis. It deals with complex shapes, difficult boundary conditions, difficult loading aspects, different type of materials, and also with nonlinear effects. The basic concept of finite element method is any continuous solutions such as stress, displacement, temperature, pressure can be composed of continuous functions over a finite number of subdomains. Here, the figure differentiates the exact analytical solution and also the approximate piecewise linear solution. In this slide, the figure represents the number of elements. So, the more number of elements give more number of accurate result. In this slide, it represents the 2-element discretization and a 4-element discretization. For 2 elements, the result will be somewhat less accurate when comparing to 4 element. Coming to elements, there are three main category of elements, that is one-dimensional elements, two-dimensional elements and three-dimensional element. For one-dimensional element, the diagram represents in one direction, that is x-axis. The remaining y-axis and z-axis can be given in terms of numerical values like area and moment of inertia. For two-dimensional element, the diagram represents in x direction and y direction. The z-axis can be represented in a numerical value with the help of thickness. While coming to three-dimensional element, the complete geometry can be modeled with the help of a modeling software, and there is no need to give area, moment of inertia or thickness with respect to a numerical value. The one-dimensional element which is used to solve the structural problems, and the two-dimensional elements which is used to solve the surface problems, and the three-dimensional element which is used to solve the solid problems. The basic equation in FEA to solve the physical problem is F equal to KU. F stands for force vector and U stands for displacement vector and K stands for element stiffness matrix. With the help of this equation, we can able to solve a physical problem and find out the result. In this slide, there is a comparison between discretization with 228 elements and discretization with 912 elements. The difference is here the element is more. So more elements has more nodes. So it gives better result when comparing to the previous one. So lesser element gives less accuracy and more elements have more accuracy. So according to one-dimensional analysis, there are two categories. One is bar element and another one is beam element. So both comes under one-dimensional analysis. The beam element deals with Bernoulli's theory and bar element deals with strength of materials theory. This is a two-dimensional analysis structure. The first diagram represents the scalar variable and the second one represents the vector variable. The development of finite element equation deals with initially direct method and next one variational virtual work method, and the final is weighted residual method. What is direct method? This method which is used to solve the simple cases, and virtual work method deals with the relations between internal and external virtual work and minimization of system potential energy for an equilibrium. And the third one is weighted residual method, which used to develop the weak form that can be incorporated in a finite element equations, and particularly it is suited for no variational statement for like stress analysis problem. Ritz-Galerkin results can be identified. In this slide, this picture represents node 1, node 2 and element 1. The node 1 indicates that a force acting in that node is known as F1 and the displacement at node 1 is known as U1. Likewise, at node 2 the force is known as F2 and the displacement is known as U2. Then the K stands for stiffness matrix. From this we derive an equation of F equal to KU. For F there are two forces, so it is denoted by F1 and F2. Also for the displacement it has U1 and U2. Then for K, that is k minus k minus k and k. While solving this equation, we get the solution to find the displacement. In this slide, the picture represents the stepped bar. There are two elements. The first element is denoted by 1 and second element is denoted by 2. The first element, the length of the element is denoted by L1 and the area of the element 1 is denoted by A1 and the Young's modulus is denoted by E1. Similarly, for the second, L2 is represented as the length of the second element and A2 is represented as area of the second element and Young's modulus 2 is denoted by E2. For each and every element, there is a equation, that is F equal to KU. After deriving the first equation for first element and second equation for second element, then after that we have to assemble and finally we get the results for unknown, that is U1, U2, U3. U1 stands for displacement at node 1, U2 stands for displacement at node 2 and U3 stands for displacement 3. So these are some standard FEA references which we can go through this to gain more knowledge regarding FEA. Thank you.